So last week, and I would get your notebooks up for this. So last week we went over decimal multiplication with base 10, but today we are going to go over, okay, we will be going over decimal multiplication with modeling. Okay, so ultimately we will be multiplying normally, but today I want to give us a visual for why, okay, I want to give us a visual for how decimal multiplication works. Okay, and this is the only one I'm going to have you draw in your notebooks, and in the future I'm going to give you actual grids. But you guys have graph paper notebooks, and I apologize if you do not at this current point in time, that have those grids built in. So what I would like you to do in your notebook right now, I'm going to give you about a minute to do this, is I would like you to make a grid, or make a box around the grids in your graph notebook that is 10 boxes by 10 boxes. Okay? So you should make a box around the grid that is 10 by 10. Okay? And it should be a square. Does that make sense? Okay. If you for some reason don't have the same notebook, please just make a box and you can put in your own grids. It does not need to be perfect. Okay. It does not need to be perfect, but do your best to make that 10 by 10 if you do not have the graph paper notebook. And while you guys are making that in your notebook, I will do one on the board. Which one is better back? The cue to me that you guys have successfully done that will be that you are looking up at me with your pencils down. Now, you guys have the grid, so you don't need to make this necessarily. So it'll take you guys less time actually to draw than it did me. And I'm saying, because you already have the grids in your graph paper notebook, you will not need to draw these lines in the middle like I had to do on the board, because you just have those grid lines. So I just want you to make a box that is 10 by 10. So there's a reason why we are doing this. So what we are going to do first is we are going to multiply decimals that are less than 1. Okay, so we are going to model decimal multiplication using this box. And the first one that I want to work with is the decimal 0.3 times 0.7, or 3/10 times 7/10. Now, in a moment, you guys will get, when we are actually doing the activity with this, you guys will have markers or colored pencils, but for now, I would just like you to use the pencil that you have, or whatever you have in your hand. Now, we'll notice that this box is broken up into how many different tiny boxes, Jack? There are 100 tiny boxes. How are we able to do that math so quickly? Yeah, how do you know that there are 100 boxes? Okay, great. We know that we have 10 at the top, we have 10 on the side, and 10 times 10 is 100, which means that inside of here there are 100 tiny boxes. So if we were to say that this is a representation of a whole, and we were to say that this entire box is equal to 1, what would we say that one of these boxes is? I'll repeat that. So if we were to say that this whole box represents 1, okay, it represents the number 1, and there are 100 boxes, if I were to fill in this here, what would that represent? 0.1. So so if there are 100 boxes, how many are there here? 1. So we would say that is 100. Now you may remember from earlier this year when we did place value that 100 would not be written like this. What would 100 be written as? Yes, Olivia? Point, not 10, because that is the same as this. But you're on the right track. No? 0.01. Great. That would be represented as 0.01. how would we want to represent 0.1? What would we have to do to represent 0.1 in this model? No? No, I'm saying on, okay, my apologies. If we wanted to represent this on this grid, what would we have to do? We have to fill in 10 boxes. We have to fill in an entire row. Okay? Do you guys sort of see that? Because we have 100 boxes here, and if we wanted to represent 1/10, you'd have to fill in 10 boxes out of 100. Does that make sense? Okay? Now, there's a reason why we're doing this. We're building up to something. In order to properly represent decimal multiplication modeling, what we are going to do, Yafet, is we are going to fill in some boxes. So the first thing that I want you to do with this up top is I want you to see that this is 3/10, and I want to write this on the side here. Okay? And I want to write 7/10 up top here. I'm going to grab a different color marker. So based on what we just did before, we represented 100, and Nahom showed me how to represent 1/10. How might we represent 3/10 going this way? What would we have to do to represent 3/10? No? You can fill in 30 boxes or 3 rows. Okay, so what I want you to do, guys, is to fill in 3 rows. Like that. So if on this side, using the green marker, that corresponds to 3/10, if you were to fill in 3 rows, what might we want to do to represent 7/10? Yes? So for 3, we represent it this way. Okay, you want to represent it down. Okay, so we represented 3/10 going horizontally, and I want to represent 7/10 going vertically. Okay, so I'm going to go from here this way. So 1, 2, 3, 4, 5, 6, 7. And I have to go all the way down, do 7 columns, because that is what represents 7/10. So I would like you guys to do that. You guys done a number of seconds to do that? Okay. So what we are interested in is to see how many smaller grids have been covered by both representations. Okay. So I want to see what boxes, what tiny grids have been marked by the green marker and the brown marker. Okay. And what I'm going to do is I'm going to make a box around those numbers. Okay, so you have that box here, and I think I heard someone just say, but how many tiny grids have been shaded by both of the representations? I can see a hand for that. I want to know how many of these smaller grids have been filled in by both of the green and the brown markers. Julia? It's 21. Okay, you see that, and you can count it out if you want to. You can count there 21, but you can also see that it is 3 by 7, and just as 10 times 10 is 100, 3 by 7 will give us the area for this. So we see that there are 21 boxes filled in. Now what I want to do is I want to represent that as a decimal. Okay, so earlier when I asked Nahom what 1 box represented, Nahom told me that 1 box represented 100. So if I wanted to take this purple box and I wanted to turn it into a decimal, what do we think it would look like? Augie? 3 tenths, and you're going to multiply it by 7 hundredths. Sorry, 7 tenths, you would get 21 hundredths. Okay? And what you've just done there is decimal multiplication. Yep. You've multiplied 2 decimals, and you've gotten a product. Yes, Sophia? Okay, so in this particular case, that might work. Yes, but that is not necessarily the rule. That happens to be a coincidence in this case. Because when you get to other decimals and when you move to the decimal place value, I don't want to say that that always works. In the type of problems we will be doing, yes, that does work. And now, why did you, you're on to something, okay? What do we notice about the numbers on the left and the numbers on the right, based on what you've seen in math before? Yeah, Thomas? Okay. I made that purple box so that you guys can see it visually, like which boxes have been shaded by both. Because in case it's, I want to make it very clear which ones are shaded by both. Okay. So what the ones that we are representing our answer are these, yes, are all in boxes in the purple. Okay. Correct. Now, what Sophia asked, and I want you guys all to see, and what Thomas also just mentioned, is that 3 times 7 equals 21. So we are definitely onto a pattern here that when you can represent decimal multiplication, it is as simple as multiplying the whole number of digits, and it's all about placing the decimal. So ultimately, in the next few days, we're going to learn the tricks. Hey, Millie up here. We are going to learn the tricks to figure out where to put the decimal and how to do that. But I hope you guys can see that 3, 7, and 21 are numbers that are common to us. So decimal multiplication is really not that much different from regular multiplication. We just have to know where to put the decimal. And we will get to that point later. Jack and then Mom.
So do you just, would you do this for everyone, or is it just for this in particular? Would you just add the 0 point for the answer? Would you do 3 times 7 equals 21 and then add the 0 point?
So we are going to get to why this works in a little bit.
But would you do that for everyone?
For this particular, for multiplication, when they are both tenths, yes, that is what you would do. But this is sort of a special case. What I'm trying to show you guys today is why decimal multiplication works through modeling. Okay? So rather than just tell you the rule, I want you to get a visual for why it works. Okay? And then we're going to get into sort of the steps, like you would in long division, as to how to move the decimal to the right place. Okay? So what we are going to do now, and I understand I've done this one a little bit more drawn out because I want us to practice and sort of do this whole class. Sorry, no. I'm going to give you guys a practice sheet so we can practice this. We will not be going over these all together until the end. But what I would like you to do is you will all get a number of problems that are like this one we did on the board, except we'll already have the grids laid out. I will come around with colored pencils and markers, and I would like you to actually shade in the grids as we did here. Now these numbers will be different, so you won't always shade 3 rows and 7 columns. The values that you have in the factors will tell you how many columns and rows to shade. Okay? Nicole, I want to get your question first.
So, wouldn't it be 3 times 7?
You are correct. So I hope that you see that pattern. I hope that you notice that. What we're going to get to soon enough is, like how to place a decimal. I don't want you to think you always just do 0 point in front, but I do hope that you see that there is a relationship between 3, 7, and 21. So I'm going to come around with colored pencils and markers for you guys to shade these in. If you already have colored pencils or things of that nature that you would rather use, you may use those.
Are they specific colors?
I will come around and give you the colors.
Is Mr. Gedlin, we shaded in any color?
Yes, but I do only have 2 different colors. So it's 2 colors.
You have to shade it in and you just need to color.
I want you to shade it in. Okay, I will come. Yes. 2 colors. go get color pencils, yes. Take some color, just two. Yeah. I think I'll need 2 colors too. Okay. Are you good with colors? You got it. Just take 2 colors, girls. That's all you need. Are you good?